I'm sure you know when an object moves from one place to another, it is called motion. When this object changes its position as a result of a force acting on it, we can say this object has its momentum. My name is Gordon Christian. Our topic for today is linear momentum part 1 under the theme conservation principles. By the end of this lesson, you should be able to 1. State and explain in your words the meaning of the laws of motion, and also know the results that lead to the equation F equal to ma. In the course of our daily activities at home, in school, at work, in the church, in the mosque, as the case may be, we often change the position of objects by moving them from one place to another. This process is called motion. When you move an object from one place to another, that is called motion. Now, the quantity of motion a moving object has is referred to as its momentum. Momentum P is simply mass in motion, or the product of a mass body by its velocity. Every object has mass. What I mean is this. For a car parked at a spot, it has mass, right? When this car starts moving, we can say the object is in motion. So momentum is simply that object in motion. The greater the mass of an object, the greater its momentum. Now look at this illustration. Imagine that 2 balls are thrown at you at 22 meters per second. One is a baseball and the other a basketball. You observe that the basketball is much heavier than the baseball. So it will be difficult for you to stop the basketball because it has a larger mass than the baseball. So one important aspect of momentum is mass. Also, momentum can be transferred from one object to another. Let's say, for example, if an object A moves in a straight line and collides with another object B, this will be the resultant force. Object A would tend to make object B move in its direction if object A has a larger mass, say 5 kg and say 2 kg. You can see there is a transfer of momentum from object A to object B. So, the more momentum a moving object has, the harder it is to stop. Just to help you understand better, imagine 2 baseballs are being thrown at you. One is traveling at 22 meters per second and the other 67 meters per second. Even if you manage to catch that of 67 meters per second, you might fall over. This is because it will take more effort on your part to stop the baseball at 67 meters per second than that of 22 meters per second. So you can see velocity is another important aspect of momentum. In physics, momentum P is mathematically defined as P equal to m times v. Momentum is simply a vector quantity. You know why? Because it has both magnitude and direction. The direction of the velocity is the same as its momentum. From the mathematical definition of momentum, we say P is equal to momentum, m, mass, and v, velocity. It is measured in kilogram meter per second or Newton second. Do you know that when an object changes its position, thereby changing its momentum also, there could be a variation? Now let's see this variation. Impulse is simply the change in momentum of a body, and it is represented with the letter I. When there is a change in the mass of an object moving, we say the impulse has been felt. This is done within a specific time. Let's see this illustration. Imagine an object A is being pushed. F, that is the force pushing the object. The object moves from point A to point B in a specific time period. The movement of this object from point A to point B in a given time t is known as impulse. we can say an impulse has been felt or exerted or experienced on this object. For example, when a tennis racket strikes a tennis ball, an impulse is applied to the ball. The racket puts a force on the ball for a given period. Impulse is therefore force times time, which is Ft. The SI unit of impulse is Newton second. Now let's see this mathematical illustration. Suppose a force F acts on a body of mass m for a given time t and cause it to change its velocity from initial to final velocity. Then we can say F, which is the force, is proportional to mass, final velocity, minus mass multiplied by the initial velocity all over time taken. Now let's remove the sign of proportionality. F, which is the force, is equal to mass multiplied by the final velocity minus mass multiplied by the initial velocity all over the time taken. By cross multiplication, that is F equal to mv minus mu all over t and all over 1. We can say Ft is equal to mv minus mu. Since we have a common coefficient for the velocity, we can say m into final velocity minus initial velocity. Therefore, impulse Ft is equal to mass into final velocity minus initial velocity. Force is simply a pull or push. This means that when you push an object, the object changes its momentum as a result of the force exerted on it. When the object moves, that is acceleration. And acceleration is simply the change in velocity all over time taken. You can see all these factors have a common relationship. Now let's see this relationship and how they work with each other. Like I said earlier, force is equal to mass times acceleration. So force is equal to mass times acceleration. Bringing down the force, we say mass. But acceleration is velocity all over time. Bringing it further, we also know that acceleration is simply final velocity minus initial velocity all over time. Summing it up for an equation, this is the acceleration. So we can say F is equal to m, which is the mass, multiplied by acceleration. So force is equal to mass times acceleration. You can see from this image, an object with a given mass m moves in a certain direction from one point to another, which is the acceleration, as a result of the force acting on it, which means F is equal to ma. Having said all this, we have come to the end of the class. But before we go, let's take a quick summary of what we've learned so far. We learned that momentum P of a body is defined as the product of its mass and velocity. Momentum P is equal to mass times velocity. We also learned that impulse I is change in momentum or the product of force and time. Going on, we learned that force is a pull or push that is applied to an object to change its momentum. Lastly, we learned that force is the product of the mass of the object and its acceleration, which is F equal to ma. Now let's answer some test questions. Question 1. Dash is a change in momentum of a body. A. Linear. B. Force. C. Impulse. Or D. Velocity. The correct answer is C. Impulse is a change in momentum of a body. Question 2. If a body of mass 600 grams moves at a velocity of 10 meters per second, what is the linear momentum of the body? A. 6,000 Newton second. B. 600 Newton second. C. 60 Newton second. Or D. 6 Newton second. The correct answer is A. 6,000 Newton second, which means 600 multiplied by 10 will give you 6,000. Thank you for your time. Till we see again in the part 2 of this lesson. Bye-bye.